Hi everyone, welcome back to chemistry. I wanted to make a quick video to help you out with post lab number 5 if you're struggling with it. I know that it was somewhat of a quick turnaround, and if you haven't had a chance to watch the videos or if you're still struggling, hopefully this will help you out. So we'll go over kind of the first part together, and then I'll let you do parts 2 and 3 on your own because they're very similar. So for the first part, you're gonna generate your table, and this will look kind of exactly like it does in your lab notebook. So we just want your observations and stuff like that, some of the data that you took. For number 2, let's look at this a little bit. So it says write and balance the chemical equation that depicts solid sodium hydrogen carbonate, or sodium bicarbonate, reacting with aqueous HCl to form aqueous sodium chloride, liquid water, and carbon dioxide in the gaseous state. So be sure to include subscripts showing physical states. So our job is to write and balance that equation. So let's go ahead and do that. So they tell us what we start with. So it says sodium bicarbonate. So if you weren't sure quite what that is, that the chemical formula is right there. So let's leave a space because we know we're going to have to balance a little bit. So NaHCO3, and we were told it was solid. And then we also have that reacting with hydrochloric acid. We were told that's aqueous. Oops, let me give myself a little more room there. Okay, and then it says we form sodium chloride, aqueous, plus liquid water, and gaseous carbon dioxide. Oops, let's give ourselves a little more room here. All right. So let's go ahead and balance this equation. So let's see. We got Na, we got H, we got C, we got O, and we got Cl. I think that's everything. So I'll write them in the same spots over here just to make it easier to compare. We should have the same things on that side, right? All right, so the first thing I like to do is I like to put a 1 here just to say I have at least one of everything. And then I'm going to count what I have now. So I have 1 sodium on the left, looks like 2 hydrogens, 1 carbon, and looks like 3 oxygens, and 1 chlorine. All right, and then on the right I have 1 sodium, 1 chlorine, 2 hydrogens, 1 carbon, and looks like 3 oxygens, because I've got 2 over here and 1 over here. All right, so actually, this is our balanced chemical equation. It's just a 1-to-1-to-1. Let me make that 1 a little better. 1 ratio. Okay, so what does this actually mean? So remember, in terms of mole-to-mole ratios, the number or coefficient in front of each of your chemicals is telling you how many moles of that chemical are reacting with how many moles of another chemical, or producing that many moles of your products. So in other words, right, 1 mole of sodium bicarbonate reacts with 1 mole of HCl to produce 1 mole of NaCl, 1 mole of water, and 1 mole of CO2. Okay, so now that we've got those there, let me just clean this up a little bit. I'm going to get rid of this part, and we'll just have our balanced chemical equation there. You could show your work if you want. In fact, that's great if you do. All right, so for number 3, we're going to calculate the molar mass. So let's actually put this as number 2. And then for number 3, we want the molar mass of NaHCO3. And this is going to help us out. So it'll be useful in the next step. So we want the molar mass, so let's write that down, molar mass. So we've got Na atoms, we've got H atoms, we've got C atoms, and we've got O atoms. We got 1 Na, 1 H, 1 C, and 3 O's. All right, now we gotta look at the periodic table and see what the atomic mass number for each of those is. So sodium is 22.990 grams per mole. Hydrogen is 1.008 grams per mole. Carbon is 12.011 grams per mole. And oxygen is 15.999 grams per mole. Whew. All right, so now I'm just going to do the calculation for this oxygen here because everything else is, we only have one of them, okay? But for oxygen, we have 3, so let me calculate that. Get out my calculator. So I got 3 times 15.999 is 47.997. All right, so now I'm going to add up, oops, sorry. I'm going to add up all of these numbers that I'm highlighting. I forgot my units here. Okay, because I want the total molar mass. Okay, so 22.990 plus 1.008 plus 12.011 plus 47.997. And that equals 84.006 grams per mole. All right, so that's the molar mass of NaHCO3. So that's for number 3. Now let's see what number 4 wants us to do. And actually, let me scoot this up a little bit. Just so we have a little bit more room to work. All right, so it says using the molar mass of NaHCO3, using the mass of NaHCO3 that you weighed out to calculate in lab, calculate the moles of NaHCO3 that you used in your reaction. So show your work. Okay, so this is the molar mass of NaHCO3. So that tells us how much that compound weighs per 1 mole, right? Per 1 mole of it. Okay, but we don't necessarily know how many moles of it we had in lab. So this is going to be different for each person. But let me just go ahead and make up something. So say we got, I don't know, say we got 5 grams of NaHCO3. So we got, say, I don't know, 5.00 grams NaHCO3 in lab. Now we want to use our molar mass to convert to moles. We want to know how many moles we actually have of that substance. So we're going to use our molar mass to get there. So we have 84.006 grams NaHCO3. Whoops. NaHCO3, right? And we want to get to moles, so 1 mole NaHCO3. And how did I get this train track here? Well, the way I got that was I looked at my molar mass and I said, well, I can actually use that molar mass as a conversion factor. And I could have written it either the way I have it written here, or I could have written it with 84.006 grams of my substance on top and 1 mole on the bottom. Okay? Sorry, 1 mole of NaHCO3. So you could write it either way. I wrote it this way, the highlighted way, because I want to cancel out these grams, because I want to get to moles. So in other words, really what I wanted to do in this, in number 4, is I wanted to know, hey, how many moles of NaHCO3 did I use in the reaction? How many moles did I put in my reaction? I don't have something that measures moles in lab, so I have to use grams and then get to moles by converting. Okay, so hopefully that makes sense. If not, let me know. All right, so number 5. So now I'm in, let me do that calculation first. So let's get rid of this here. And let's do 5.00 divided by 84.006 is going to give us 0.059519558 moles of NaHCO3. And let's just make sure we are rounded to the correct number of sig figs. So there should be 3 sig figs because that was our measured value, right? So we should have 3 sig figs in our final answer. So we want that number right there that I've highlighted. So actually, I'm just going to go ahead and erase this part here. And that's going to be my final answer. So that's how many moles you put into the reaction. Remember, your number is going to be totally different, right? Everybody's number that they actually used in the lab is going to be different. I just made this number up off the top of my head. Okay, so you're not going to expect to get what I got here. Okay, you are not going to get the same thing. But I wanted to make a number up just so we could keep working on this. Okay, all right, so for number 5, 5 says using the molar ratios between NaHCO3 and NaCl in the balanced chemical equation above, determine the number of moles of NaCl that should have been produced in the reaction. So I think this one, the reason it's kind of tripping people up is this term here, stoichiometric coefficients. So let's break that down just a little bit. So you'll hear that term sometimes. Every chemist is different, but you can hear that term sometimes, and it's basically talking about those molar ratios. So what's a molar ratio? Remember in the beginning of the video I said 1 mole of that thing reacts with 1 mole of this thing to give us 1 mole of this, 1 mole of this, and 1 mole of this. Those are your molar ratios, your mole to mole ratios. Whoops. Those are your molar ratios, or your mole to mole ratios, or your stoichiometric coefficients. That's all saying the same thing. Okay, so just some different vocabulary. Okay, so but what we want to do is use the molar ratios between. Let's see. Let's get rid of these highlights here. Between this and NaCl in the balanced equation to determine the number of moles of NaCl. Okay, so our goal is to go from, let me write this down. Our goal is to go from moles of NaHCO3, which we just found over here, to moles of NaCl. So let's go ahead and see how that's done. So I'm going to use my number from above. So from number 4, I got 0.0595 moles of NaHCO3. And I want to get 2 moles of NaCl. So how am I going to do that? Well, because I have a balanced chemical equation up here, I actually know what ratio those moles react in. So it looks like 1 mole of NaHCO3 produces 1 mole of NaCl. So it's just a 1-to-1 ratio. So we actually don't have any math to do here because this is going to cancel out. And because it's a 1-to-1 ratio, that's basically like saying I'm going to take this number here and multiply it by 1 and then divide by 1, which just is going to give me back the same number, right? So kind of feels like we're doing something wrong here, but we're not. Moles NaCl. All right, and remember, you're not going to get this exact number because you didn't use the same number that I used in lab. You're putting the mass that you actually used in your lab. You're going to need that from your lab notebook. All right, let's see here. Okay, so we're done with number 5. So let's check out number 6. All right, number 6. Convert the moles of NaCl to grams. Okay, moles of NaCl. So that's this. That's what I just calculated in this step. Okay, so we want to convert moles to grams. So let's go goal, moles NaCl to grams NaCl. Okay, so we're going to use the moles we just calculated. So 0.59, oops, missed a 0. 0.0595 moles NaCl. And we want to get now to grams. Okay, now we're going from moles to grams. What connects moles and grams? Yeah, molar mass. Molar mass. So one more step. Actually, there's going to be a couple. So molar mass of NaCl. So we got to use our trusty handy-dandy molar mass calculation. So Na22.990. Where did I get that number? Periodic table. Yeah. Chlorine 35.453 grams per mole. Sorry, that's a G. Can't write today. Haven't written all weekend. Okay. So let's see. 22 point. Oh, sorry. We'll just add it like this. So we're adding those two numbers together because we want the molar mass of that entire compound. So 22.990 plus 35.453 is going to give us 58.443 grams per mole of NaCl. All right. Now, what can we do? Okay, so now we have the molar mass of NaCl, and that's what's connecting grams to moles. Remember, this number here is telling you that for every 1 mole, right, there's an imaginary 1 there. For every 1 mole of NaCl, it weighs 58.443 grams. So let's go ahead and plug that in. So we got 1 mole of NaCl. And 58.443 grams of NaCl. And now we can cancel out our moles. Again, you could have used this equality both ways. You could have put the 58.443 grams on top and moles on the bottom, or you could have flipped it. And you will, depending on what you're trying to eventually get out in the end, right? We want grams, so we wanted to cancel out those moles and put them on the bottom. All right, so let's do the calculation. So we got 0.0595 times 58.443, and that's going to give us 34 point, oops, no, it's going to give us 3.48. Let's go 3 sig figs, so 3.48 grams of NaCl. Again, this is not going to be the same number for you, right? None of these are going to be the same number. None of these are going to be the same because we didn't start with the same measurement of our reactant. Okay, so let's just take a second here and let's look. So in number 2, we wrote a balanced chemical equation so that we could use that equation to figure out some of these numbers down here. So in number 2, we wrote a balanced chemical equation that's showing the reaction we did. And we knew those, we knew what the chemical equation would look like because it told us in this question exactly what we were putting in and getting out of the reaction. Then we calculated our molar mass for our reactant, NaHCO3 for our carbonate, okay? And that was so that we could use that molar mass to get from the grams we measured in lab to the moles, because I don't have a molometer. I can't measure how many moles I added. And the reason we wanted to be in moles of our carbonate is so that we could use the mole to mole ratio from our balanced chemical equation up here to get from moles of my reactant to moles of my product. And you could have done that with any of those products on the right side. You could have done that, but we wanted to know how many moles of NaCl specifically, because that's what the question asked for, so I converted to moles of NaCl. In the next step, we went from moles of NaCl, so from moles of NaCl to grams of NaCl. And how did we do that? Well, we used our molar mass for NaCl, right? Just like we did up in this step. Okay. Phew. All right. Now, what does number 6 say? It had one more thing that I wanted to mention. So it says this predicted amount of product that should form is called the theoretical yield of NaCl. So what does that mean? So we calculated how many grams of NaCl we could have produced if everything in lab went according to plan. So we put in this many moles of NaHCO3 and we got out this many grams of NaCl. And we don't know if we got that much out. This is just the theoretical yield, right? This is what we could make in theory if everything in lab went amazing. That means nothing was lost to the container, no one spilled anything, all kinds of things just went according to plan. But since we're human, that's not gonna happen. There's always gonna be a little bit that's lost. And that's okay, okay? We don't expect your theoretical yield to be exactly the same as your actual yield, what you actually made in lab. All right, so let's try to figure out, though, how much did we actually make in lab? So how many grams of NaCl did you actually recover from the reaction? Now, for number 7, that's going to be in your lab notebook. And in fact, I actually want to say in your lab notebook over there, too, because, again, you're not going to have the same number there as I have. I just made that up. I don't even know if it's close to what you got. It's been too long. All right, so let's see. 8, you're going to calculate the percent yield of NaCl for this reaction. So how do you calculate the percent yield? Remember, percent yield equals your actual yield from number 7 over your theoretical yield from number 6 times 100. And that times 100 is actually just to put it into a percentage, okay? So just times 100 and that'll give you a percent. Okay, I'm not going to do that part for you because I don't have a number for number 7, but I think I think you got this. What about for number 9? It says discuss why your percent yield is not 100%. What factors could have contributed to the yield being high or low? I messed up or human error are not sufficient answers. Yeah, so if you get a percent yield that is higher than 100%, what might have happened? Remember, we dried your carbonate in the oven. So what if it wasn't dried quite enough? Could that lead to too many grams in the end? Interesting. What if your percent yield was less than 100%? Why do you think you would get a number that was less than 100%? Okay, I'm not going to do that one. Tell me what you think. I hope this helps. You're going to do kind of the same process for the other 2 parts. And of course, let me know if you have any questions. If you need a little extension on this one, just email me and let me know. Okay? All right. Have a good rest of your day, you guys.